So post-lab question number 3 gives people a lot of problems. So let's go ahead and do it. It's the ultimate Hess's law problem. So we're asked to find the enthalpy change or the enthalpy of this reaction between sodium chloride solid and sodium chloride aqueous. Okay, so this is what we're given, but we have all these other 6 reactions, so we can label these 1, 2, 3, 4, 5, and 6. These 6 reactions with their corresponding enthalpy. But the problem also tells you, if you notice carefully, it's asking you not only to utilize these 6 reactions, but an enthalpy change that was measured in this experiment. So the enthalpy change that you're going to use in this experiment is going to be the first reaction, and that is the HCl NaOH mixture. Now when I did it, I got a value of minus 63.2 kilojoules per mole. So that reaction is also going to be the 7th reaction that we're going to do, and somehow uses Hess's law on all these 7 to try to get this reaction here between sodium chloride solid going to sodium chloride aqueous. So the first thing we want to do is sort of write everything down and tabulate it. Okay, I'm going to box this reaction here. Let's go ahead and actually use our first reaction. Our first reaction that we calculated is HCl plus NaOH goes to NaCl aqueous plus H2O liquid. I calculated that, your value may be different, as minus 63.2 kilojoules per mole. The reason why I want to do that is my NaCl aqueous that's on the product side is also the NaCl aqueous is on the product side of the delta H reaction that I want to calculate. So let's go ahead and write our neutralization reaction here along with the corresponding enthalpy. All right, so once again, I want to remind everyone why I chose the reaction between HCl and NaOH, our first reaction that you did in the lab, and the enthalpy that we calculated from is because the NaCl aqueous is on the product side, the NaCl aqueous is on the product side on that reaction. So NaCl solid, let's look at our table here. So the NaCl solid, where can we find that? That's going to be reaction 3, but you notice in reaction 3 the NaCl solid is on the product side. So let's flip it to get it on the reactant side. And remember, when we flip a reaction, we're going to flip the sign. So we have our lab reaction. Now let's also add to it reaction 3. So I numbered these reactions. We're going to add reaction number 3 to this. So not only will we add reaction 3, but we will also flip it. So flipping it gets the NaCl solid on the reactant side, which is a good thing. And that goes all the way to, looking at our sheet here, Na solid plus 1/2 Cl2 gas. All right, remember I flipped this, so now instead of minus 411.1, it's going to be positive 411.1. All right, again, let me tell you why I did that. Highlighting in orange, here's my NaCl aqueous, that's good. Highlighted in orange is my NaCl solid. Okay, that's good. Now I need to get rid of all the other stuff, basically. So I need to cancel out the Na solid, half Cl2, HCl, NaOH. So what reaction can we utilize to do that? I'm thinking here, Na solid, half O2 gas plus half H2 gas. NaOH solid. We can do the Na solid, I'm looking at this, can actually cancel out with the Na solid here. So let's go ahead and add reaction 2 to here. All right, so adding reaction 2, my reasoning behind that is I'm going to cancel out the sodium solids. So the sodium solids, one by one, I'm going to knock all of these out till I get the oranges as the only thing that is not left out, that's not crossed out. So I was successful in crossing out the Na solids. And let's see what else is out here. I want to cancel out the NaOH solid that is on the product side in reaction 2. Here's the NaOH solid. And I see, looking at this, if I add reaction 6, I can get the NaOH solid on the reactant side to cancel out with the NaOH solid on the product side. So let's add reaction 6 to this. Okay, so again, to rationalize why I'm adding reaction 6 to this is because the NaOH solid is going to cancel out with the NaOH solid here. I want to cancel out everything except the orange, what's in the orange boxes, because what's in the orange boxes is my reaction. And now I have a whole bunch of other stuff here. Let's look at the, how about that H2O water here? The H2O water. Another thing is that H2 gas. So let's look here and see what we can figure out. Let's look at reaction 4. This catches my eye here. I have the H2O liquid on the product side. Here I have H2O liquid on the product side as well. So to cancel out the H2O on the product side here, I'm going to flip reaction 4 to get H2O liquid on the reactant side. So flipping this will actually make this positive 285.8. So here I'm going to say let's flip reaction 4. Okay, flipping reaction 4 actually was pretty beneficial to me because see, the 1/2 O2 gas and the 1/2 O2 gas cancel out. Also, the H2 on the reactant side here cancels out with the H2O there. This is what I calculated. Everything in purple is what I'm getting from the problem set. And so I still got a lot of canceling out to do to still only have my orange, the reaction in the orange boxes left over. So what else can we do here? We used 2, 3, 6, and 4. Let's get that HCl aqueous out of the way. The HCl aqueous can get out of the way if we just simply add reaction 5, leaving it totally untouched. All right, so adding reaction 5, the benefit of that is my HCl aqueous will cancel out with my HCl aqueous here. Now what can we do? We still have a lot of other stuff here. The only reaction that I have not utilized is reaction 1. So if we look at reaction 1, half H2 plus half Cl2 goes to HCl gas. And the HCl gas here in reaction 1 will cancel out with the HCl gas here. So let's go ahead and add reaction 1. And adding reaction 1, okay, so rewriting reaction 1 here, half H2 gas plus half Cl2 gas goes to HCl gas. It's 92.3 negative, so not touching anything because I'm leaving it as is. I'm not flipping it or multiplying it by any number. All right, so the rationale behind doing this was that the HCl gas cancels out with the HCl gas. The half Cl2 will cancel out with the half Cl2. And we have here, if I'm going to put this in a green box here, so this 1/2 H2 gas plus this 1/2 H2 gas here, both are on the reactant side, add up to 1. So this plus this, that 1 H2 half plus half, will cancel out with the 1 H2 gas that's on the product side on this reaction. So if you notice here, everything has canceled out. By the way, I forgot to cancel out the NaOH aqueous with the NaOH aqueous here. So everything has canceled out and I'm left with my net. And my net here is this reaction. What's the corresponding enthalpy for this reaction? It's going to be minus 63.2 plus 411.1 minus 426.8 plus a minus 41.8 plus a 285.8 plus a minus 75.2 plus a minus 92.3. So doing all of that on my calculator, I'm getting an answer of minus 2.4 kilojoules per mole. And this is how you do post-lab question number 3. So notice this Hess's law problem. You have 7 reactions. This is the reaction that you did experimentally. These 6 are from the data table. Out of those 7 reactions, we had to flip 2 of them and then add the rest in a very specific sequence. So